Hello and welcome to another concept video of Dissected U Solutions. This concept video is on highest common factor. If you have not already seen the DIY activity for highest common factor, then I highly recommend that you watch that first and come to this video after that. So what really is a highest common factor? In very simple terms, if you have two numbers which have so many different factors, and if you select the common factors, and out of those, if you select the largest one, the highest one, that is the highest common factor. But where do we use these highest common factors? What is the application of highest common factor? Why do we even need to study them? Let's see a couple of examples where you actually need to use highest common factors in real life. And that's what will make you understand why understanding this concept is such an important thing. So let's get into the example. Now imagine if you are going to redecorate your room and you decide that you want to make a design of wallpaper. We are talking about the left hand side of the screen. You want to apply wallpaper on one of your walls, and that too in the form of these bands. So you want a yellow band and a black band and a yellow band and a black band. Let's say this is the design that you are going for. What is the easiest way to do it? You just go and find yellow and black wallpapers and you try and see if you can find the band size which you are looking for. But in real life, that doesn't happen. Most of these wallpapers are available in standard sizes, and you may have to actually cut these wallpapers to fit your size, to fit your design. So this is one place where you would need to use HCF, and you can use the concept of HCF to maximize your utilization of resources and minimize the wastage. How? We'll see that in a bit. But let us understand the question. Let us understand the second situation where you would use HCF. So this is an imaginary situation which has been created to make you understand what are the kind of situations where you would need to use HCF. We have three containers. All of them are of different sizes, and we need to fill these containers with some water or maybe some other liquid. And the only condition is that you are given a mug. And the condition is that you can use the mug fully only. You cannot fill half the mug and pour it into the container. You have to fill the mug fully and then you can pour it into the container. Now, if you want to do the least number of times of bringing the liquid and pouring it in, then highest common factor is the way which you can optimize the mug size and find out which mug size will satisfy these conditions. Let us look at the solution of these problems to understand them better. So let's say you have, you go to the shop and the shopkeeper says that, yellow roll is available only in 15 inches size and black roll is available only in 40 inches size. So now you are, if you are in this situation, then you cannot have those equal size bands in your design. You will have to cut these rolls. And if you are going to cut these rolls, you want to minimize the wastage. And how do we find which is the broadest strip that you can remove from these rolls without wasting is by using HCF. So let's say, how do we find HCF? For 15, I'm going to find the prime factors first. So 3 into 5. These are the prime factors for 15. For 40, I'm going to do the same. So 2 into 2 into 2 into 5. So 2 into 2, 4 into 2, 8 into 5 is 40. Now between these two, which are the common factors? There is actually only one common factor, which is 5. And that's why you choose that 5 as a common factor, which incidentally in this pair of numbers is also the highest common factor. So highest common factor between both these numbers is 5, and your broadest cut of the roll can be of 5 inches. Let's try and check it. So in the 15 inches roll, the yellow one which you're getting, you can actually pull out 3 of those bands which are of 5 inches in size. And for the black roll which has 40 inches breadth, you can actually get 8 rolls of 5 inches breadth. So these kind of circumstances, you can easily find out how many bands or how many cuts you need to make in such rolls, and what is the optimum design that you are going to get out of whatever resources are available. Let's look at the second problem that we talked about, and here it is. You have a small bucket which is 12 liters in size, you have a medium bucket which is 18 liters in size, and you have a large bucket which is 24 liters in size. And you have to find out the size of the mug which you can use for filling all these buckets. It has to be the largest mug, and it has to be the mug which you need to fill full. You cannot have half mug filling the buckets. So then what do? You find out the factors of whatever these buckets capacities are. So 12, we can factorize it into 2 into 2 into 3. So these are all prime factors. You can always find the prime factors using prime factorization method. In this video, we have skipped it for the sake of time and for the sake of quick explanation, but you need to follow that method to find out these factors. Same way for 18, we would do 2 into 3 into 3, we would get 2 into 3 into 3. And for 24, we would get 2 into 2 into 2 into 3. So now let us see which are the common factors. We have 2's here, which are common. So I've put 2 here. And then here we have a 2 and a 3, but here we have only 3's. And we have here 2 2's and 1 3. So what these 2's, they are not common. No more. Only the first 2 is a common factor. The other 2's are not common. There is 1 3 which is common among all the 3 numbers. So we are going to write 2 into 3 is common. And then there is nothing else which is common. The only 2 numbers that are common between all these 3 sizes, bucket sizes, is 2 into 3, 6. So what does it mean? You can have a mug size of 6 liters to fill all these buckets. That way you will have to pour least number of times, but you can pour without filling it halfway. If you fill full, then also you will be able to fill these buckets. Let's cross check that. So HCF, we have found out 6 liters, our mug is of 6 liters. For filling the 12-liter bucket, we would need to fill it twice. For filling the 18-liter bucket, we would need to fill it 3 times. And for filling the 24-liter bucket, you would have to fill it 4 times. So with all these buckets, we can use the same mug and fill all of them. So hope you understood the application of HCF, or highest common factor, in real life. It is usually used for optimization of resources. If you have any doubts, then you can definitely go back to any part of this video for explanation. And I hope you would be able to understand the concept clearly once you have watched it. Thank you so much. Happy learning.
All the materials used in this activity are available in DBox along with other learning and teaching aids. For more information on DBox for home use, school program and CSR program, visit the link given in the description of this video. If you found this video helpful, then please hit that like button and share it with your friends. And if you have still not subscribed to our channel, then do subscribe and click on the bell icon to get all updates. We hope to see you in our next video. Happy learning!